Hi there, welcome back to my channel. In this video, I'll be taking you through limits of functions problem. Okay, so I have a special problem here, and it says solve the limit as x squared minus x cos x approaches what positive infinity. If this is the first time being on this channel, kindly subscribe to support. Please watch this video to the end. So let's see. So it says limit of functions, right? Limit of functions. So we have limits as x approaches positive infinity. Limits as x approaches positive infinity of the function x squared minus x cos x. Okay, now limits you know that the limits as x approaches infinity, that's positive infinity, of cos x doesn't exist, does not exist. Okay, this does not exist. For that reason, our function here, how can we find the whole limit if some part of the limit doesn't exist? For that reason, we cannot solve this. In order for us to solve this problem, we need to introduce a nice concept here, which is we need to introduce a nice theorems. So one theorem is saying that if you have two functions g of x and f of x, such that g of x is less than or equal to f of x, right? So where you have our x near a certain point x naught, then our limit as x approaches x naught positive or negative of g of x, right, of this, if this limit is equal to positive infinity, then obviously our f of x limits as f of x also approaches positive, x naught positive or negative, will also be equal to positive infinity. Why? I am a smaller function, this is a bigger function. If my limit is approaching infinity, how much more the bigger one, right? So me, the smaller, mine is approaching infinity. And you know infinity is something that doesn't end. Then obviously the bigger one will also approach infinity. That's the whole concept. Now let's see the second part. Then also if limits, right, as x approaches x naught plus or minus of f of x, okay, is equal to negative infinity, then obviously limit as x approaches x naught of plus or minus of g of x will also be equal to negative infinity. So this is the other way around. If the limit of the bigger function is negative infinity, then obviously the limit of the smaller function will also be negative infinity, because this is bigger than you, and even the bigger one is approaching negative infinity. You, the smaller, will also approach us negative infinity. On that note, let's try and analyze our problem here. So it's a limit as s approaches positive infinity of the expression x squared minus x cos x. So this is a problem I'm talking about. Here's a problem I'm talking about. So how do you solve such a problem? So let's see. Using the principle I just explained, the theorems, right? You realize that you need to get two functions to compare. You need a bigger one, you need a smaller one. Is that not it? Right? You need a bigger one and you need a smaller one. Okay. So now you know that you have cos x, right? So right now, because x is approaching infinity, right? Because x is approaching positive infinity, you see that x is greater than or 0. Is that not it? You see that x is greater than or 0. Therefore, cos x will be less than or equal to negative x, and will be greater than or equal to negative x, and will be less than or equal to what? Positive x, right? So at this point, what can I do? I have to multiply both my left and my right side by what? By the value what? X, right? Or I can add x squared to both sides, right? I can add x squared to both sides. Is that not it? Yep. So let's see something here. So if I add x squared to both sides, what am I getting? I'm going to get x squared here minus what? X, right? Less than or equal to what? Cos x less than or equal to x squared plus x, right? Something like this. Okay. So once you have this expression here, right? Once you have this expression here, you simply have to find the limit on this side and this side. Though this function that we're having here is what? Cosine of what? X, right? This function that we have here is a cosine of x. So you see that our f of x here is greater than or equal to what? X squared minus x. this is less than or equal to x squared plus x, right? X squared plus x, right? So we are trying to do this so that it will help us eliminate, it will help us find the cosine part, because the limit as cos x approaches infinity does not exist. So we need to still find it so that we can find the limit of the entire function. We need to get rid of that non-existence, right? So using this theorem, we can get something nice to help us find the limit of this entire function. So right now, I have to find the limits as s approaches positive infinity of this function, limit as s approaches positive infinity of this function, or even of this one alone is good, right? So any of them should satisfy our condition. So let's see something here. So our limit as s squared here. So limit as s squared, let me write it here, limit as s squared minus x, which is the left side of this, s squared minus s approaches positive infinity, is going to give me what? Obviously, we are going to have what? Positive infinity, and you have also so let me do this. It is the same as x minus 1, right? Yeah. So this will help us so that you get positive infinity multiplying positive infinity minus 1, right? So this is the same as what? Obviously, we're going to have if you have infinity minus 1, obviously the same as what? Infinity. You can't subtract 1 from infinity and expect it to change. So this is my positive infinity multiplying what? Positive what? Infinity. And this obviously was positive infinity. So now we've realized that the function cos x, right, which is greater than what? This function, right? This is a bigger function. Cos x is bigger than this function. And if this function has a limit approaching infinity, positive infinity, obviously this one, which is the bigger function, also have a limit approaches what? Positive infinity. So using that as a stronghold, obviously we can make this function this way. So now our function, now we know that the limit as this alone approaches infinity will become what? Something like infinity, okay? So therefore, the entire function will have a limit so that you have, let's say, x, you have, when I bring this, I'll have positive infinity, right? So positive infinity, so I'll have, let's say, x open bracket, x minus what? Cos x, right? X open bracket, x minus what? Cos x. But we don't want to introduce this here. We don't want to introduce this here. We don't want to introduce this here. So now we are just going to use the comparison alone. We are just going to use the comparison alone. So we found out that this smaller function. So now what is s squared minus x here? So the s squared minus x is simply just this part of the function. The s squared minus x is simply just this part of the function, right? It's simply just this part of the function. So we are just going to use this theorems. So we know that the function t of x alone, this function cos x is greater than what? This whole thing. Remember, this is greater than this whole thing, right? From here. So we know that whenever this is approaching positive infinity, cos x will automatically approach at positive infinity. And therefore, if two components of these functions are all approaching positive infinity, then obviously the limit as this entire function approaches positive infinity is equal to what? Positive infinity. That's all. Thank you for being with me in this video. Don't forget to like, subscribe, and share.